This is part 2 of my phase lock loop Tesla core video. In the first part I was able to show that it worked and it wasn't really set up optimally, and I was running it with a little half bridge. So anyway, just to recap, I have an interrupter, which is this circuit developed by John Fro that can use the 60 Hz line frequency to generate variable frequencies up to 30 to 60 Hz. And this one is connected to the enable pins on these UCC inverting and non-inverting gate drive transformer chips. I'm using 2 separate gate drive transformers here and here on this full bridge. The last setup used a half bridge. This thing is set so that it generates a frequency. The voltage controlled oscillator in this CD4046 chip generates a frequency that is out of resonance, so it's below the resonant frequency of the secondary. So when I turn it on, current will be flowing through the 6-turn primary, but it won't be the right resonant frequency to drive the secondary. And I'll show you that in a minute. You might see a little bit of output, but not much. But there'll still be a good bit of current flowing through that. Once the frequency of the voltage controlled oscillator hits the resonant frequency of the secondary, this will start to produce some significant RF and output, which will be picked up by this feedback antenna, and this goes into pin 14 of the PLL CD4046 chip, and will lock onto it. So this thing should stay in resonance once it gets close to the correct frequency. So here's the basic setup, and let's check it out. By the way, we're going to use 110 volts line frequency to run this thing, and I'm sure I could push it up higher if I had a way of getting a higher voltage, such as 220 volts. Hang on a sec. Okay, I'm just plugging in the core right now. There's a tiny bit of output from it, even though it's not in resonance. Now I'm going to increase the frequency till it hits resonance. Here goes. So it looks like it works pretty well, and there is some heating of the MOSFETs. They're warm. They probably need fans on them because there is quite a bit of current flowing. And I can actually change the duty cycle by adjusting this. You know, I've set this to a kind of a middle duty cycle, but I can even increase that more. And that's the frequency, as you can see there. Well, thanks for watching, and come back to check on the status of this project. I plan on rebuilding that coil with 34 gauge wire, making it like a 5-inch tall coil, and seeing if I can get similar kind of output. I also plan on reducing the length of all the wires and getting things much more compact to reduce stray inductance.